This is part 2, ready? So 4-9, scientific notation, part 2. We're going to start with continuing with some of the problems that we were working on, changing a number that's in scientific notation into standard form, so making it into a regular number. Remember, scientific notation is where you have one digit in front of the decimal point, and then the other digits go after. And the times 10, it's always times 10. And we base that times 10, the exponent, on how far we move the decimal point. Alright, so for this one, since we have a -6 as our exponent, that means it's a small number, so we need to move the decimal to the left. How many spots are we going to move it, Gabby?
6.
Good job. The exponent tells you how far to move it. So if you see that negative, think small number, and think moving to the left and 6 spots. So we're going to move 1, 2, 3, 4, 5, 6. Remember, we're adding zeros. So that gives us 0.00000341. Number 5. Now that's a positive 8. So is that going to give us a big number or a small number, Gabby?
Small number.
Nope. If it's a
big number.
Big number, right. Okay, so we're going to find our decimal point. If you don't see it, it's in the back. And since we want a big number, that means we're going to go to the right here. And for every move to the right, we need to add a 0. And we added 8 zeros, which basically gives us 600 million.
That's a big number.
That is a pretty big number. You are correct. Number 6. If you haven't already done it, would you try number 6 on your own? Okay, looking at our 2 previous problems. If we have a -6, Gabby, is that going to give us a big number or a small number?
Small number.
Negatives are going to be small. Do you remember which way we're going to move the decimal point?
Left.
Very good. We're going to move it to the left because that's going to make it small. Excellent memory. Okay, so our answer would be 0.00007. And moving on.
That was pretty fast.
That one was pretty fast. Alright, next we have multiplying with scientific notation. So now, a lot of times you'll have 2 numbers that are in scientific notation and you have to multiply them. And this is where it kind of makes a little bit more sense and it makes it a little bit easier. So we have 2.1 times 10 to the 8th times 1.5 times 10 to the 6th.
So those 2 have to be times?
Yeah, but we're basically going to break it up into 2 parts. Okay, so we're going to take our whole numbers and we're basically going to take the 2.1 and the 1.5, we'll multiply those together, and then that'll be a big times, and then we're going to multiply the 10.8, or not 10.8, I'm sorry, that's 10 to the 8th times 10 to the 6th. Now you haven't done multiplying decimals yet, so we're not going to worry too much about that. But when you multiply those 2 together, you're going to get 3.15. And then you haven't had this yet, but they have, so they should know that when you have 2 bases, when the 2 bases multiplying and the exponents are the same, you add the exponent.
So on number 3, you're gonna times 15 times 10, and then you're gonna add 8 and 6 together, and you add the answers together to get your answer?
Not exactly. Nice try, though.
I was thinking.
Well, hey, I like thinking. Thinking's a good thing. It was a good trying. What we did is we multiplied the 2.1 and the 1.5
together.
So
you're going to multiply them together?
Yeah, you multiplied those 2 to get the 3.15.
So you're going to multiply the answers? Or divide or something?
No. And then over here, since when you multiply and you have exponents, if the bases are the same, you add the exponents. I know this is a little bit hard for you, so if you're not totally understanding it, it's okay. You'll learn more of this later on. This is a lot of new stuff for you. So our answer would actually be 3.15 times 10 to the 14th.
So we only add the 2 exponents?
Mm-hmm. Very good. Yeah.
Oh. I was right with one part.
Yeah, that's a start. That's a start. So here's another example. We're going to multiply these 2 together. So again, we're going to multiply the 2 first numbers together, so the 5.63 times the 3.14. So that's actual work that we have to do. Then we're going to have the times 10 to the what power? we're going to do times 10 to the 7th times 10 to the 8th. When the bases are the same, we'll add the exponents. So 5.63 times 3.14 is 19.142. And then we keep the times sign. And then we did the 7 plus 8, which will be 15. So we have 19.142 times 10 to the 15th. And we're trying to write this in scientific notation. Now, do you remember, is this in correct scientific notation?
Nope.
Can you tell me, very good, can you tell me why?
Because there are no zeros.
It's okay not to have zeros. The problem is if you look at that 19.142, it has to be less than 10. So we need to move remember that?
So it has to be...
Where could we move the decimal so that we could get that number to be less than 10?
Can move the decimal to the 1. Behind the 1.
The first one?
No,
the one in between the 1 and the 9?
No.
Or the 1 and the 4?
The 1.
No, you're looking at Gabby's looking at the 10 to the 15th.
No,
Gabby, stop, hold on. We're looking at the 19.142.
Oh, I think we can move it to the first one in 19.
Yeah, we need to move it. So it's not in scientific notation, so we're going to move it one spot to the left. That makes that smaller. And if that makes that smaller, that makes that larger. So we need to add 1. Since we moved one spot, we're going to add 1 to it.
So it's 1.942 times 10, 16.
10, yep, basically. Okay. I would say it a little differently. It's 1.9142 times 10 to the 16th, or 9 and 9,142 10,000ths. Times 10 to the 16th, but that's way too hard to say. So that's our answer. So would you please try these two? And if you can't get them, it's okay, although the numbers are fairly easy. So these are ones that you might be able to do in your head. So we're going to start, so pause the video, do as much as you can, and then come back and we'll help you out. Or you can see if you got them right. So the first thing we're going to do is we're going to multiply, we're going to move things together, the things that are alike. So the 1.5 and the 4 we're going to multiply. And then we have the 10 to the 5th and the 10 to the 9th. So if you do 1.5 times 4, that's basically 6. You a little tired today? Yeah. And then we have 10 to the 5th times 10 to the 9th. Bases are the same, so we'll add the exponents.
So that's 14.
Very good, yeah. So we'll have 6 times 10 to the 14th. Now, before we go any further, we want to check.
Those are a little easy.
Yeah, those are easier numbers. So, Gabby, is that 6? Is that smaller than 10?
Yeah.
Okay, then we're okay. It's in scientific notation. That's our answer. So next, do you know what we're going to multiply? The first two numbers we're going to multiply? Number 2? Any guesses?
10 minus 2 and 10.
We are going to do those. So that's actually the second thing we're going to do.
Oh, 4 times 7.
7. There you go. Sorry, I got a little rush there. And then we're also going to do the 10 to the 5th times 10 to the negative 2nd.
Because they're both 10.
So the bases are the same. So we're going to add those exponents. Do you know what 4 times 7 is?
4 times 7. I should have from 28.
Very good. Now,
I just think of 14 plus 14. Yeah.
Hey, that works. So if we have 10 to the 5th plus 10 to the negative 2nd, 10 to the 5th means I have 5 tens. 10 to the 2nd means I owe 2 tens.
So that means it's 30?
Not 30, but that's a good guess. It's actually 3. I think you were on the right track there. So we have 28 times 10 to the 3rd power. Now, is that in scientific notation?
No, because 28 is larger than 10.
Very nice. Excellent work. So that means we need to move our decimal, and we're going to move it to right behind the 2. So if that's smaller...
So it's 2.8 times 10 to the 3rd power?
No, if that gets smaller, then I need to make that larger.
4?
Very good. So we'll have...
So it's 2.8 times 10 to the 4th power?
Very good. That's exactly what it is. All right, here we have 2 more. go ahead and try these, and then come back, and Gabby and I will help you out, see if how you did. So what do you think we're going to multiply the first things we're multiplying here?
2.5 times 4.
Good job. And then we'll also have, and that'll give us 10. And then we're going to do the 10 plus 8 was 18. Now is this in scientific notation?
And nope.
Nope, we need to move that decimal, don't we?
We can move it to the one.
In one spot. So if that makes that smaller, then...
So that means it's going to be 1.00 times 1019.
Very good. Excellent. That makes that larger. So we get 1.0. You could put the other 0, but you don't need to. Times 10 to the 19th. Very nice job. Okay, number 4. So what are we going to multiply?
I'm going to multiply 9.7 and 8.6.
Yeah, and this is where if you wanted to use a calculator, I wouldn't mind too much because it's a little bit of work, but not too much. You should be able to do it. And if you multiply that out, you're going to get 80.
You could just write it out on paper.
Yeah, absolutely. So and we have 83.42 times 10 to the negative 11th. Big yawn there. Now, is that in scientific notation?
No.
No. So we need to move the decimal again. We'll move it one spot.
So it's 8.342 times 10 to the negative 11.
Okay, but then that means that's going to get larger.
Oh, so that means to negative 12?
That's a good guess because you haven't done negatives. But actually, negative 12 is smaller than negative 11. Would you rather...
Oh, right. I remember from that video.
Okay. Do you remember? Because would you rather owe me 12 monkeys or 11 monkeys?
11.
Yeah. So that's a better number for us. So it's actually going to be 8.342.
Thank you, 10. I'd rather do 10 than 11.
There you go. Times 10 to the negative 11th. Now we're going to put these in order. And the easiest way to probably do this is to just write them as decimals. So I'm going to write, and this isn't really in scientific notation, but so we have 19 times 10 to the negative third. So I'm putting that into a normal number. So remember, if it's a normal number, negative exponents means it's a small number. So I'm going to move my decimal point 3 spots to the left, making that 0.019. 2.5 times 10 to the negative fourth, I would write as 0.00025. And 1.889 times 10 to the negative fourth would be 0.000189. Now, be very careful. Make sure you line up your decimal points. Now, after this, it's kind of easy. Once you get this set up, you can just start comparing. So we're going to compare left to right. So if we look left to right, I think we need one more line. There we go. They all, in the first column, they all have zeros. In the second column, that's going up and down.
Zeros.
They all have zeros. In the third column, the first one has a 1. So that means it's the biggest number. And then, so then that means that's the smallest. And so there's our smallest. That's our middle. And then there's our largest. So that's probably the easiest way to do it. You can also kind of look at the exponents, and sometimes they'll help, but you got to be careful and make sure that they're in scientific notation, because that first one isn't. And since it isn't, that could mess you up a little bit. So there's the answer. And that's it for today.
The end.
The end. Thank you very much. We'll talk to you later.
Looks like somebody strangled it.
Strangled it?
Like a tiger or something.
And I'll shredded it up. All right. Hey, sure. Why not? Okay. That's it.
Last time it was bloody.
Yeah, I changed it around.